So I want to start by talking about ordered pairs, which is going to help us with graphing and also representing situations. So here I have a table that's got categories and amount spent. We could take this table and turn it into ordered pairs, but like the first coordinate would be a word. So this could be an ordered pair: food, comma, $7,729. An ordered pair is just two components that are written inside parentheses. And when we write our ordered pairs, they go in these two pairs, like the two values connect together with our input and our output. Sometimes they are an X or a Y. Sometimes they are called independent and dependent variables. So in this case, the independent variable is the category. The dependent variable is the food, because the amount spent is going to depend on what category it's in. So when we write ordered pairs, we are just going to pair those up together. Like if I'm writing for housing, that ordered pair would be housing, comma, $19,884. So you get the drift on that. We don't normally, we're not used to seeing ordered pairs written in that form, but it is possible to do. So we're going to move on and talk about the rectangular coordinate system. It looks like this. You're probably really familiar with it. It has a horizontal number line that is called the x-axis, and it has a vertical number line that is called the y-axis. So here we have our horizontal number line called the x-axis, and then we have a vertical number line here that we call the y-axis. The intersection where those join together, where they meet in the middle, is called the origin, and the origin has an ordered pair that is 0, 0. There are 4 regions that we call quadrants, and they start in the top right with quadrant 1 and they go counterclockwise. So quadrant 2 is here, quadrant 3, and quadrant 4. Each point has a unique ordered pair that's called the point XY or PXY. So I could locate any spot on this coordinate plane by using those two numbers. So if I had the point AB, I would go left and right A units and then up and down B units to get to that point. The numbers X and Y are called the coordinates of point P. More on this later. So we're going to look at the distance formula that helps us figure out how far it is between two ordered pairs in the coordinate plane. The distance between any two x coordinates, we would just subtract their x values and then do the absolute value of that. But to find the distance between two actual points on here, the distance between PQ and the distance between QR. So for PQ, since PQ is on the same horizontal line, to find the distance between P and Q, I'm just going to subtract their x values. So I would take the x value for P, -4, subtract the x value for Q, 8, which would be the absolute value of -12. So the distance between P and Q is just 12 units. The distance between Q and R, since they're on the same vertical line, I will just take the y coordinates. So take 3 from point Q minus -2 from point R inside absolute value. So that would be the absolute value of 5, which would be 5. So now I know that the length of this side of my triangle is 12 units and the length of this side of my triangle is 5 units. If I wanted to find the distance between P and R, since they are not on the same horizontal or vertical line, I'm going to have to use the Pythagorean theorem. So remember, by the Pythagorean theorem, we have Pythagorean theorem, remember that was a squared plus b squared equals c squared. The hypotenuse is the c squared. So if I wanted to find the length of the hypotenuse, I would have to do c squared equals a squared plus b squared, but then take the square root of both sides to just get the square root of a squared plus b squared. So in this case, the distance between these two ordered pairs would be the square root of 12 squared plus 5 squared, which is 144 plus 25, square root 169, so 13 would be the distance between those two ordered pairs. Because I don't want to do like all of this extra work every single time, we're going to use the distance formula. But keep in mind, basically what we did was we subtracted our x values, and then we squared that value. We subtracted our y values, and then we squared that value, added them together, and took the square root. That's essentially what the distance formula does. The distance formula calculates the distance between two coordinates, x1, y1, and x2, y2, on an xy coordinate plane. The distance formula always gives you a positive value because what we're doing is subtracting and then squaring. When I do the distance formula, I try not to memorize formulas as much as possible because my memory is really not that great. So when I'm doing the distance formula for my own self, I just think of it like subtract the x's and then square it, and I subtract the y's. Ooh, those should have been further apart. Subtract the y's and square that, and then I take the square root of the whole thing. So let's practice that between these two ordered pairs here, between -8, 4 and 3, -2. So the distance is going to be, it's a big square root. I'm going to take the x's and subtract them. And with the distance formula, it does not matter what order you do your problem. Like, it literally makes no difference. So I can do -8 minus 3, or I can do 3 minus -8. It's not going to matter. -8 minus 3 seems more convenient to me, so I'm going to do -8 minus 3 squared, plus, then I got to do the same thing for the y's, 4 minus -2 squared. By the order of operations, the next thing I'm going to do is the work in parentheses. So I got -8 minus 3, which is -11 squared, 4 minus -2, which is 6 squared. Next thing I'll do is square those values. -11 squared is 121, and 6 squared is 36. And then add those two numbers together, I get the square root of 157. I think 157 might be prime. I'm not 100% certain, but if it's not, then you should try to simplify the radical. And if you remember doing that in previous sections, that's where you just do the prime factorization, do that number tree, take your pairs out front. But that's all there is to the distance formula. So let's apply that distance formula to decide if we have a right triangle. So we've got 3 vertices of a triangle that we're trying to decide if it makes a right triangle. So the first thing we're going to do is find the length of the sides, and then we're going to see if they make the Pythagorean theorem true. So we're going to find all 3 sides and then see if it makes a squared plus b squared equals c squared. So I got m at -25. And then n, I am not drawing these to scale or anything. I'm just putting 3 points on my paper. And then q at 10, -11. So I want to find how long is mn, how long is nq, and how long is mq. I got lots of distance formulas to do. So let's go. For mn, I'm going to do the square root of, remember I subtract the x's, so how about -2 minus 12 squared? And then I'm going to subtract the y's, 5 minus 3 squared. So that's going to be the square root of -2 subtract 12 is -14 squared. And then 5 minus 3 is, of course, 2, which is going to be, I need my calculator. I think 14 squared is 196. 14 squared. Yes, 196 plus 4. So we got the square root of 200. I don't really care about simplifying this right now, unless the question in my math lab asks me to simplify it. If it does, then I would break down my 200 probably into 100 times 2, and then 10 times 10 times 2, which gives me a pair of 10s to bring out and a 2 to leave in, so 10 square roots of 2. If it asks me to find the distance between the 2 points, or it asks me what is the length of that side, then I would have to do the simplifying, but otherwise, just go ahead and leave it square root of 200. And I'm going to do a similar process for the distance between n and q. So between n and q, subtract your x's. I might just do this faster. 12 minus 10 is 2 squared. And then 3 minus negative 11, 3 minus negative 11 is 14. So I have 2 squared plus 14 squared. Oh my goodness, is this the same exact thing I just got? Square root of 200. So these two sides are the same, square root of 200 and square root of 200. And then I'm going to do the third side, between the distance between m and q. So I've got negative 2 minus 10 is negative 12 squared. 5 minus negative 11. 5 minus negative 11 is 16 squared, which would be the square root of 144 plus, what is 16 squared? 256, which would be the square root of 400. Square root of 400 actually is a thing. I believe it's 20. Yes. So then this side here is 20. In order to check the Pythagorean theorem, I have to know which one is the longest side. Well, the square root of 200 is smaller than the square root of 400. So this 20 would be my C side. So then I'm going to check to see if a squared, square root of 200 squared, plus b squared, square root of 200 squared, is equal to c squared, 20 squared. Square root of 200 squared is 200, and the square root of 200 squared is 200, and 20 squared is 400. So yes, the Pythagorean theorem works, which means it is a right triangle. In fact, we could classify it a little bit more specifically because we have two sides that are the same. So we could actually say it is an isosceles right triangle because two of the sides are the same. But if they don't ask, we don't have to tell. All right. Another application of the distance formula is going to be determining if points are collinear. So to find out if 3 points are collinear, we have a little note here. What we have to do is figure out if the sum of two distances is equal to the third distance. So we're just going to find, again, 3 distances. So we've got the distance between P and Q, P and R, and Q and R. So PQ, we do the square root of negative 1 minus 2 squared plus 5 minus negative 4 squared, which would be the square root of negative 1 minus 2 is negative 3. Negative 3 squared is 9. 5 minus negative 4 is 9, and 9 squared is 81. So this is the square root of 89. Did I mess that up? 9 and 81. Oh, 9 and 81 is 90, y'all. Square root of 90. Square root of 90 simplifies. So I can make that a 3 on the outside, 2 times 5 on the inside. So that is 3 square root of 10. Okay, what about QR? QR would be the square root of 2 minus 4 squared plus negative 4 minus negative 10 squared. 2 minus 4 is negative 2. Negative 2 squared is 4. Negative 4 minus negative 10 is the same thing as negative 4 plus 10, which is 6, and 6 squared is 36. So QR has a length of square root of 40. Square root of 40 simplifies into, that breaks down to 2 times 2 and 2 times 5. So I get a pair of 2's out, 2 times 5 left in, which gives me 2 square roots of 10. And then the third length I have to check, I did PQ, QR, now I need to do PR. So PR. The distance formula, so I do negative 1 minus 4 squared for the x's, and then plus 5 minus negative 10 squared for the y's. Subtract your x's, square it, subtract your y's and square it. So that would be negative 1 minus 4 is 5. 5 squared is 25. 5 minus negative 10 is the same as 5 plus 10. So that's 15 squared, which is 225. So that is the square root of 250. 250 would break down into 25 times 10, which would be 5 times 5 and 2 times 5. So a pair of 5's outside, 2 times 5 inside. Okay. All right, now to check if it's collinear. If it's collinear, then if I add 2 of the distances together, I would get the third distance. So I want to add the 2 shorter distances, so 3 square root of 10 plus 2 square root of 10, and see if that is equal to the third distance of 5 square root of 10. So what I remember about adding radicals is as long as I have the same radicand, then I can add the coefficients. So 3 square roots of 10 plus 2 square roots of 10 would be 5 square roots of 10, and that is equal to 5 square roots of 10. So yes, they are collinear.